All right. Um, Wonderful to have everyone here in this tutorial. This is the first talk of the day. I'm based in Ireland, but today I'm in India. I'm on my holidays, and today I will be talking about how to build contextual chatbot using LLMs, vector databases, and most importantly, Python. I'm a senior data scientist and a manager in EY Ireland, and in my part time, I love to do some community work, including being the education lead at Women in AI Ireland, which is a non-profit do tank organization where we encourage more women to join the AI space, and not just in like technical capacity, but also at executive levels for beginners and practitioners alike. Now, coming starting with this massive blowout that we got after the introduction of ChatGPT, the world changed after 30th of November 2022 when ChatGPT was released. We got a lot of news ranging from, having how accurate the responses are, how it's going to, snatch all our jobs. Is that the end for Google search engines? Um, but but in the process, we figured out is that having GPT or the LLMs is a boon for our industry. We figured out in the last 1 year not just how we can generate accurate answers, but also how to use it to benefit our businesses, how well we can leverage it, not just for generating answers, but also like for multiple other tasks behind the scenes. For example, for expediting classification, annotation, text annotations, tasks for very large text-based data that used to be very, very complicated. Today, they have all become much more easier, and that's all because of the starting of ChatGPT. Uh, I think uh, the end of last year. Okay, so what is at the crux of ChatGPT, or what is this entire thing about? It's all about generative AI. We are able to generate content that we've not seen before, or the structure of it that we haven't seen before, but it's based very much on the training data that it's seen and been trained on. Um, uh, um, the whole AI ecosystem, where does generative AI lie? So we'll start with AI. What is AI? AI is an ecosystem of algorithms or machines that understands and has the ability to, predict something in the future. A system that has the ability to learn from, past data points, and then, predict something further. A subset of AI is machine learning, where machines learn based on the provided data, and deep learning, it does the same thing but using artificial neural networks, but has the ability to learn more complex patterns within the data itself. And where does generative AI fit in here? So there are different kinds of tasks that AI or machine learning strives to accomplish, including discriminative tasks and generative tasks. The discriminative tasks are more around classification or identification predictions, and generative tasks are more about generating content or generating texts and images, and that is where generative AI comes in, and it is based on neural networks in the heart of it. And where does LLMs sit in this whole ecosystem? It is a conjunction between machine learning, deep learning, and generative AI, because these are models that serve generative AI, but they're also ANNs and traditional machine learning um, concepts as well beneath it. So basically, in the heart of generative AI, there's behind the scenes, it's a large transformer model that has all the worldly knowledge up till the date it has been trained on. That comes with that disclaimer always, up till the date it has been trained on, but it has massive knowledge that has from whatever it has publicly available on the internet. And it always comes with some sort of drawbacks as well, but we'll see about it later. Now that we're talking about large language models and how we've grown from, models that would be only in a range of like features of only of thousands to having like trillions of features in in them, and which is given us really really high accuracy. But then, how does it compared to the existing ones? So what we have today is GPT-4, which is the latest one, GPT-4 Turbo to be specific, the latest one to be released. And it has got about 1.7 trillion parameters, which is 1,000 times in that of the GPT-3. Which has already been like really, the efficiency of GPT-3 was good. GPT-4 is even better. But the question is, how far do you think, how can we how much can we scale our parameters, our features so much? uh, Efficiency is going to increase, right? But um, can how are we going to manage the infrastructural costs in that sense? So because holding that large feature set is very difficult. But yeah, so large language models, they range up to like billions and trillions of features, as you can see on the screen. And GPT-3 has about 1 billion, and GPT-4 has about 1.7 trillion parameters. So behind the scenes, how it works. So like I said, that it's a very large transformer model. uh, there was a research paper that came out a while back, which was about how we can use attention, self attention, which is technique to use to build these transformer models. It basically, a transformer model basically has two components, basic components. One is the encoding component, the other one is the decoding component. The encoding component encodes incoming text in certain format, and the decoding component is tasked to understand patterns and decode that encoded component and learn from the patterns while decoding it, and especially by predicting blank blank text within the incoming texts. And that's how large language models work at a very high level. Okay. um, and it accomplishes all of this by learning from a very large amount of data. That is number one. Number two, from billions and billions of parameters that it learns from these encoded components while decoding it. And this is an unsupervised learning technique, which is also massive because while we've got like uh, you know vast in vast information in the internet, but it's not possible for us humans to just annotate each and every one of them, because for supervised learning you need to provide an explanation, a label for every single article that you feed in, or like for a specific task, whatever. For that kind of vast information, it's literally impossible for us to provide metadata along with it. So therefore, unsupervised learning in large language models and transform models have been really really helpful for us to derive benefit from information without it being a very laborious task. Um, in terms of applications of LLMs, the first thing that comes to your mind when you see ChatGPT, your ability to interact with the questions and answers, your ability to ask cross questions on top of the questions that you've already asked, that has opened up doors into marketing, sales, and support. That was the main focus when it first started. When I attended some talks, people were talking about how it can enhance customer support. And I think that's the first sector in the industry that has embraced or started experimenting with generative AI or LLMs, just to begin with. um, how it can do it, it can scan records, it can generate insights, it can send like human like responses, which was missing from rule based engines initially. It can also what it can also do is it can do some general writing or note taking. Note taking, you must have seen the applications nowadays in Zoom. Um, I've seen like some of my teammates in Women in AI, they take automatic notes when they're absent from the calls. And for general writing, we've seen use cases where we've generated job descriptions for our recruitment teams and for for social media content as well, which is which has been really beneficial to draft like that first draft using really fancy words, and given if you give proper instructions like what smileys to add, if you at all want smileys, if you want it in bullet format, if you want it in three sentences, or if you want long text, whatever instruction you pass into the LLM, it it responds in a in a detailed fashion. And the next one, very important, code. And we've been seeing we've been massively using code copilot, Microsoft's copilot as well. And I tested it. It's very efficient. And I personally worked on some, code generation techniques. It was very crude. It was before the LLMs came in, generative AI came in, and I can tell you, I can promise you, it was a really, really difficult task. But since LLMs came in, and then I started looking at these co-pilots, and I was like, okay, could do a lot more with this. And it's actually very good for learning coding as well, and writing very efficient code, improving your code quality. um and then migrations as well. Like if you use it well, you should be able to leverage LLMs for removing a lot of the mundane part of your software engineering routine. And in terms of the others, image and speech image and speech synthesis, and then video generations, well, you can use them for for your good, but then you have to be beware of the the not so good applications of LLMs, which is rampant nowadays. I think I've seen a lot of spams have increased, a lot of a lot of spams have increased nowadays. But then, yeah, so these are roughly the applications of LLMs. And today, what we our agenda is to look at how do we design a chatbot that understands context and then can respond back to you. That can respond back to you in natural language. It refers to an information, a pool of PDF data that you pass it in, and then it should be able to answer you by reading through the document and present that information in a more like natural language manner. Okay, so then now we are riding the open AI wave. We have so when it came in, we kind of when we started looking at what it can do, like we didn't know when it started what are different questions that you can ask. So yeah, we can definitely, I've asked the question like, can you generate job description like template for a data scientist role, or like asking factual questions as in who won the football world cup in 2000, or like asking for some kind of advice, medical advice, or like whatever. And then and then very importantly, as software developers, or like I'm not a software developer, I'm a data scientist. So even like for writing scripting code, I can I was testing with some different kinds of um, code that it can generate. Like well, I asked it to generate some code for heat map using Seaborn. It did not do very well, but then it did try to do a lot of things that I think traditionally none of the large language models could have done. And then summarization tasks, and then everything on the like all the WH questions, what is, when was, how to's, where is, and generate some kind of a template, or generating stories. you know we were testing chat GPT almost every single day. But what enabled that that huge wave, like I would rather call it a tsunami, because it was it was overwhelming. And the first and foremost reason for it being so popular is, number one, um, people who are not from software or computer science background, people in business and commerce, they wouldn't interact with AI at all, um, because AI would be something very exotic that would, very, very brainy people could only interact with. But what ChatGPT or OpenAI did is that it gave it an interface and opened it up for people to start using, of course to their own benefit, because they were using the feedback that they were getting from these people who were testing it. But the ability to interact with an AI agent in normal language was a massive plus factor for why ChatGPT, or ChatGPT particularly, became so popular. And then the uncanny ability to answer all the questions that you ask. Yes, the hallucinations were tough to ask. You could trick it into answering questions and everything, but I asked questions like something about space, like sun and moon, that would be really you know difficult for it to answer, but it was like answering everything correctly. And I was really shocked when I was testing it for the first few days. And also its terrific problem solving skills. It's not just doesn't answer factual questions like, you know, from which side does the sun rise. It was actually as answering mathematical questions as well, and drawing inferences and reasoning based tasks, which was also very, very impressive. Also, after once I learned prompt engineering, it also you know I was getting surprised even more, like with proper guidance or proper prompt engineering, how well you can get the desired output, or make it do the thing that you want the LLM to do. So that's why that's why there was this huge wave of open AI. And here's one thing that came out of it is prompt engineering. Prompt engineering ruled 2023. And here's a little example of how it happened. So the first example that was there in the previous screen was generative job description for data scientist role. And here in this example, I have fleshed it out a little bit more and gave it some context, gave clear specifications on what exactly do you need in that job description template, what format do you need. So in the format, I say that can you add a job summary, key responsibilities, and benefits. So basically, clearly defining what is the output structure to it. So these are a couple of principles of writing a good prompt: to give proper context, to give clear specifications, and to have a clear format in output, input, and output structure, so that it can get the information and can structure it and give it out to you in a more digestible manner. And that's what prompt engineering is all about. um, and then and not just that, it's also an iterative process. So when you see the output for that, you would see like you probably will have some stuff in bullet points. You won't have everything in bullets. You might have like a full paragraph of what skill sets are required. But if you want the response in bullet points, you can actually mention that again in the next prompt and say like, can you put it in bullet points? Number one, you can put it in, give me a JSON output as well. All these kind of things you have to build it iteratively. So if at first go, it's very difficult to get everything right. It's a very iterative and a process that requires a lot of patience, to construct something that gives exactly what you need for. um and yeah, so with that, we'll go into a little bit of hands-on basic prompting demo. Um, I will post the GitHub repository link here now. So if you want to follow along, That's I will be using OpenAI's basic prompting, the notebook, which contains a basic template or how you should be doing it in Python in your notebook. Okay, so when you start doing it, first you will need to install OpenAI, and you need to register for your OpenAI key. All right, you need to open your OpenAI account, get your API key, set it up. You can directly use it here. You can directly use it, put your API key here, but since I usually use the OpenAI key and then I will be presenting, not allowed to share my API key, I keep that in my environment variables, and this is how I fetch it, os.environ, and then I have this the key whose value is the API key. Um, in this in this in this the first important code is here, which is basically your backend code for your ChatGPT interface. um so first I instantiate OpenAI. Okay, I initiate it with my OpenAI, my API key, and then look at this. I have tried to use the chat completions module from OpenAI that allows you to use models GPT 3.5 Turbo and GPT 4 as well in the chat completions one, because these school of GPTs are suited for question answering sort of tasks, not just like uncontrolled generation. This is specifically trained to answer questions or perform tasks, and it is designed to take in instructions and perform accordingly. Okay, so what you see here is first, so that's the module that I call in, and these are the arguments that I sent in. The parameters that we have here is one, the model itself. So you have the ability to select which model that which model um, you want to use. 3.5 turbo, you want to use, there are other models as well apart from GPTs. No, I think there's only GPTs for the chat completions. For temperature is another um, important parameter which allows you to tell the model how creative you want to go. If it's zero, that means you want it to be very factual. You have a context, stick to the contents, that's what you're saying to the model. And then if you go up to one or more than one, so the range is 0 to 2, more than one it's more gibberish, and if you go close to one, it has the ability to go creative, generate whatever it is. 0 0.5 balances out creativity, factual, and every single time you get a different set of responses, whereas with temperature 0, the variations are relatively low because it's more factual, and it picks the most likely most likely next words, or most likely words that could, that fits your answer. Okay, that's temperature. That's the role of temperature. Messages is where you set the context. That's where you do your prompt engineering more. It contains a role, and it contains a content. So the role says who is this speaking to the model. System is the model's environment itself. When you say role system and then you put in a content for it, you're basically setting the environment or the context. Like I've told ChatGPT that you're a recruitment assistant who helps in writing job descriptions for advertising, amazing opportunities within XYZ, and bring, write the right talent in. That's where I'm saying, who is this agent? That's the role for system. And then role user is us, who is asking the questions, who's trying to get something out of, this LLMs in the backend. And that content is basically the prompt or the question that I'm asking. Okay, when we get the response, that is basically the AI, the agent's message that gives you the output, the response, and that's the response that I had received. And it says, sure, here's the, um, here's a job description for data scientist position, and says this is the title, location, insert locations. This is a template, so it just gives you spaces. That also gives you um, uh, sorry, I can hear some echo from the audience. If you want to mute yourself, that would be great. Okay. And then you got company XYZ, and it picks up directly from this information here within XYZ, and it also ignores this little spelling mistake there I did not notice. And then it's got responsibilities and requirements, private qualifications as well. I did not have any specific instructions to fill this up, but then this is your first draft. You can definitely go back and say, can you put in XYZ in your preferred qualifications as well. And then says to apply, please submit your resume, blah blah blah. Now what else do I want it? I said that, okay, so this role is for Dublin, Ireland, and can you tailor it for an Irish audience? And what it does, it adjusts the location, says the location is for Dublin, Ireland, and says that the data scientists join our team in Dublin, blah blah. So so what I've done here is, number one, I've given a clear instruction as in what I want. I have said in what format I want. I added a few clauses that it needs to take care of. I added a content,
Sorry,
a system
Nabanita.
message.
Uh, Somebody's just asking if they can take like a quick 1 minute to set things up. I don't know if you want
Oh,
to
sure.
maybe.
Do you want any help? I can give you 2 minutes. We have a lot more content to follow. What you can do is, where can you tell me where you are at? Yeah, the repo is quite straightforward.
I think it's just probably just getting everything installed and set up.
Hmm.
But hopefully all caught up now on setting up their API.
Okay, great. So when you use this notebook, you can directly put your API key in here instead of this. So like that. Okay. So that would save you some time from uh, putting in your API key in your environment variables. You can do that later. But yeah, the code is pretty straightforward. You can also like not set a system message at all. You can just go for your user's role, and then just start giving instructions. So what it does, it detects if the role is system, then it understands it's an environment setting, the context for the conversation to start, and then for role user, it'll start sending back some responses to your queries. You can also pass in more messages, append more messages from the system, from the AI as well. Your conversation between the role user and the role AI agent, and you can pass in context along with your prompts in that scenario. But this is a very very simple example, and while you're at it, I'll go back to my PowerPoint presentation now. Okay. So now that you're aware of the things that we need to use, one is the roles in OpenAI chat completion module. One is the sister system, the user, and the assistant. The system, like I said, sets the context of the environment. Who is the bot? what are the general rules. So if there's anything that the bot needs to take care of, as in, you know, don't answer if somebody asks something out of context. So if this is a recruitment assistant, if somebody asks about auditing, like, no, I'm not answering that question. So you have to set that rule in the system or the environment. For the user is, so it's like us, ask a question, riddle, whatever, you need to give clear instructions, like I've said before, and a clear like output format. If you give very clean structured input, it can give you, you know, better answers, because then it understands it much better. And then the assistant is the response that you get from the LLM. These are the three roles that you'll find in the module. And then the models. So what we are looking at today is the chat completion one. That's the second one in this column. The first one is the language one, where a text goes in and text comes out. That was how it was. And when the GPT 1, 2, Neo, these came out, GPT 3 came out, you know, it's just text goes in, text comes out. I've experimented with loads of them. You know, it's great for like open-ended generation, which does not have to, you know, take in more instructions from, you know, from the prompt. But when it comes to chat, the second one, it takes instruction specific instructions that you have in the prompt, and then it responds. Therefore it's more controlled, has some dependency on, you know, what you're asking for. And then the embeddings is the codes or the vector representation of these input texts, the way these transformers. So we have already talked about this large transformer model that runs in the backend, and we've talked about the encoder and the decoder in the backend as well. That encoder, when it, you know, when it decodes the representation of those inputs, it sets into a very large, in this case, in GPT, you know, 4's case, 1.75 trillion. So it just, you know, creates all those numeric representations per word, per correct character, so that it can process the information in the backend. So these embeddings are also accessible to us, from OpenAI and from, you know, Hugging Face as well. So Hugging Face is another repository of all the different, you know, other generative models, LLMs as well. It has all different kinds of different kinds of models, of language models, chat completions, or, you know, even just generating embeddings. It has a repository of all that, but, you know, today we will concentrate on OpenAI. um so yeah, language, chat, and embeddings, for three types of it. And so now that we've seen, like, it has got so much great stuff that you can accomplish from LLMs. I hope everybody is set up. All you need to do is go to OpenAI, create your own account, get your OpenAI key, and set it up exactly where I have your underscore open underscore API. Uncomment that line, put your API key, comment this next line where I have set my OS environment key, and, you know, just run. You'll be able to access the model. um okay, so now that we have already discussed about what the great things that LLMs can, you know, accomplish, what it can also do is it can present incorrect or false information that you're already aware of. That hallucinations, it can give generic information, whereas when a person asks for a specific response, wouldn't get that. um, Information can be outdated, could be inaccurate due to, you know, wrong contextual references. Might not, there's loads of ambiguity. Well, from a traditional NLP standpoint, ambiguousness is one of the biggest challenges in, you know, text processing tasks. We have we have a massive improvement by using LLMs for removing ambiguity. But then ambiguity comes in even more advanced form. So if LLMs get confused about the context, it can bring you inaccurate information, and therefore you have to be very careful, as in, you know, whatever LLM says, you might that might not be exactly true. So you can see there's an example there. Who won the 2024 presidential election? Says my knowledge was last updated in 2021, and you should be, I'm unable to provide information about events that occurred after the date. So you have to look up to the news source, but just doesn't say that 2020 we are yet to go into 2024. It's not possible. So it still gives you the possibility of getting the answer. Okay, but then that's um uh, that's something that we can handle ourselves internally when we design systems based on LLMs. It can also be biased or non-compliant with laws or regulations. There have been loads of conjectures about being it being biased and non-compliant, and then not following correct AI governance processes. What it does is it hampers for intelligent people. It's easy to locate. For people who believe it all, it'll be difficult for them to locate exactly where LLMs have gone wrong. So it generates based on probabilities. It doesn't know, it doesn't understand, it doesn't process anything like humans do. um so that's first. And the second thing is token limitation. That has been very difficult for us to solve because when I started with, I was like, okay, I fed in some good bit of information and asked a few questions. It's like, oh my God, it can just do all the comprehensions really quickly. But then comes the challenge of feeding like a big PDF, like 50 pages PDF, and asking questions about it. Like, how do I do? And it has only a few bits of token limitations, and we got and there were loads of conversations around how we could tackle this challenge. There are methods in which we can summarize the pages and then summarize the next page, and then compress that information into smaller chunks and then feed it into the context. But then how many times would you have to compress information to pass to fit into the token limitations? So all these kind of things that also reigned 2023 this year. Conversations around how to tackle this context window limitation. And LangChain came in as one of the saviors in terms of tackling that issue. And today we will see how we can do it. Okay. um, okay. So that comes with that we come to LangChain, and and then, so what LangChain does is it gives us the ability to interact with a multitude of documents. It could range from videos to audios. You have, YouTube API as well that gives you access to YouTube's transcripts. I use it once to, get, a long transcript for some kind of LLMs application building. And then you have the ability to read PDFs. You have the ability to get audio transcripts as well. So you basically have the ability to access data in a format that you can use for training your models or giving context to your models. What it also gives you is the ability of storing that information, because imagine 100 pages PDF that you got extracted all the embeddings. You need somewhere to store it. You cannot store everything in the memory. So it gives the ability to interact with storage databases like ChromaDB. That's what we're going to see today. There's Vice as well. And then what it also does is that it gives you the ability to interact with different kinds of models. So not just OpenAI. We're not talking about OpenAI. We're also talking about Hugging Faces and all the other on-premise models that you can build. It gives you the ability to interact with them. So it's built a full ecosystem with which you can build applications powered by large language models. It gives you the ability to extract, transform them into vectors, store it, and bring in context, gives you similarity results as well under the hood, and gives it to the model and helps the model to understand that data and give back the user relevant information or desired information. It's a So the things that you need here to download is to install a stick token, PyPDF, LangChain, and ChromaDB. Just put that in the chat, and and then we will go into while you start doing that. Um, we can go through this architecture diagram to understand, to process how it happens, what's the flow of what's the flow of information there, and how do we utilize LLM from the chat interface. Okay. Is there any question? I can take a few questions and wait for you to set up. Okay, I don't see any questions, so I'll start explaining what we're doing today. So, like I said, the first thing that we need to do is we need to convert all our data into a format that the models, the LLMs can use. The fundamentals of machine learning is converting everything that you have in numeric format, in digestible numeric format, that any kind of model can read and understand, because there's it's all a game of numbers and under the hood. So first and foremost, starting from the left hand side, we have this part from data that gets chunkified into n number of chunks. Then each of these chunks get embedded, and then they are put into a vector database um, that stores all these numbers. Okay, that vector database for us today is going to be and ChromaDB, and you need to store all of that. We'll see how accomplish that in the code. Why we need to chunk is that we need, if it's a very very large data set or like PDF, we need to put them into smaller chunks so that you can handle them well. If you generate these embeddings well, or you can structure them correctly, it'll be easy for the vector database or LangChain's modules to retrieve it in a better fashion. Okay. then then there are designing concepts as well. If you put in like chunks, these chunks can have overlap so that it retains some context from the previous chunk and has some context from the chunk that comes after. So these are all for having more efficient retrieval. So it's all about answering the correct question, right? And that's how the designing patterns they get established. So you have the data, you put them into different chunks, and then you go into, you embed them, store it in the vector database. Now what happens from the chat interface? From the chat interface, the incoming arrow is the question that you have asked. So the question gets embedded as well, because the model has to understand the question as well. So you have to convert your question in natural language into numbers, and then use semantic search, which is basically similarity technique for understanding how similar these texts are. So basically relating the what has been said in the question to understand what kind of information is in the vector DB, um, get the most similar context, and then fetch that from that, put that into the model as the context in the role user context is going to have that, just that information that it fetches from vector db, and also passes the question along with it as the question, and the LLM then generates a response that comes back to the chat interface as the response for the question that you've asked. So so you need to be prepared. So every time you process any kind of PDF or any kind of data, you have to refresh your vector DB. Today I've used a random PDF for for this presentation that I have vectorized and put into the database. If I have to change, if I change that, if I change that PDF, or I add in more PDFs, I'll have to refresh that entire training or creating vector database code so that it refreshes with the new embeddings, and then you can ask questions related to those PDF information, and then you get the context, you feed the context along with the question that you asked to the model, and then you show it on the chat interface. So what for the chat interface, I've used Streamlit today. You can also use Gradio. It's also been very well, very popular this year for the chat interfaces. I find Streamlit a bit better, and I've been developing on Streamlit for a while, so I thought it's more easy for me than learning radio. Um, so yeah, is there any questions so far? If not, I'll go straight um, into the next notebook that tells you how to use LangChain um, to ask questions to your LLM and feed a created vector database and refer to the vector database to get the context and the answer to your question. Retain information in the memory. So basically, your chat history in the memory, so that you can, ask, you can refer to them while you converse with the LLM. So that's the link there. Um, there it is. Okay, so we'll go through this notebook now. Um, it requires you to install. So the LangChain pip install dependencies I had. So you need to install TikToken PyPDF along with LangChain before LangChain, I guess. So the cost for running these notebooks for the workshop, it's going to be very low if you set up your API key. It's just like when I started, it was free. I got like $20 credit, and I could not even spend like $2 out of it because I was testing, but like I was sending loads of queries, but then it did not even end up spending like $2 out of the $20 credit. So it's pretty cheap. It would only like be less. It would be less than like 50 cents, I think. Okay, so we go through this notebook. So what I have here is, first I set like, so the model here is I've used text embedding ADA 002. That's the embedding model which generates the embeddings. What we will do is we have this folder, data folder. Um, I haven't provided any PDF data in the repository at all. So what you can do is you can create a folder called create a folder called data, and add a sample PDF in it. Okay. Whichever, like whatever you like. So I've used Globe. So Globe is one of the Python libraries that helps you navigate through your data folder your folder structures, right? So I have used Globe to say, so this is the PDF that I had downloaded from the internet just to show you how this works. Um, this is the model, and this is the vector.db directory. So I just named it as vector.db/chroma. So inside this, the vector database is going to get created, and all the embeddings are going to get stored in there. I just demoed that. This is how you can access all your PDFs. So the star says, this says that everything that you have got inside your data folder, get all the PDFs, all the star.pdf, all the PDFs in the data folder. And then what I've done here is I have used PyPDF loader, which comes out of the box from LangChain, to load the PDFs iteratively, and then use it for splitting. Okay. Um, and then append each of them into this docs list. And then after that, what I've done is, so like I said, you have to split the documents or put them into, smaller chunks, because you're dealing with really, really long pieces of text, and you need to make them smaller, and also, have, design it intelligibly so that it fits your model context window, but it also is able to relate to the information that you have previously. Okay. And how do they work? They split the text into smaller chunks, and then they start combining, and then after that it sums all of these chunks up into the larger chunk until a certain size, which is 2500 here in this case, is attained. And once you reach that size, and it makes a chunk its own piece of text, and then starts creating a new chunk of the next step for the next chunk, with some overlap with the previous one, and that overlap size is what we say set here as 250. To customize the text splitter, you need to know how you want to split the text, and what is the chunk size that you want, and what is the overlap size as well that you need. And in this case, we've used recursive character splitter. So what it does, it instead of taking just the length to split, it tries to search these characters in the text, and tries to retain, like if there's a paragraph, retains the paragraph, or it's a sentence, it retains the sentence as it is, so it doesn't break from in between. So it reserves the context within it, and it tries recursively, first tries to find these two, double next lines, and then the next line, and then the blank space, this kind of structured order, until it goes into the smallest chunk size, that is, it satisfies that equation. And then that's how the chunk size is developed. And then once it's done, so this is where I've initiated it with the numbers, and then I've gotten into splitting the documents again, which is the natural following step. And then now that we've done that, next step would be generating the embeddings for those chunks, right? Following the previous diagram. So in the embeddings, what I've done is I've called OpenAI embeddings from LangChain, and what it does is it creates the embeddings. So I have set my OpenAI key, so you can pass your OpenAI key again directly here. And then I've already set the model as GPT 3.5, set that, and set that the chunk size for processing this is 16. This is not a requirement for this one. I had developed this for Azure's deployment initially, so that this is a mandatory one for Azure's deployment, but you can ignore it for your notebook. Okay, so this what it does, it initiates and generates embeddings, and then in this step, in the next cell, I store them into the vector DB. The one that we've used this time, and this one is Chroma DB. And from this documents, I've put in the embeddings, the splits, and also the directory in which LangChain is supposed to store the encoded versions of the PDF that I've passed in. Yeah. And like I said, why we need embeddings, we need these embeddings. So you can say you can say embeddings are more like vector databases. Sorry, our embeddings are like word vectors, which are basically numeric representations of text, which helps us assess how close they are in context to the to other texts, and that helps us to retrieve context or retrieve answers traditionally and even here. But it's just that LMs are even more powerful, and therefore they have the ability to get even more accurate results, and generate more, human-like responses. So once we've done that, we've created the data vector database now from from the embedding setting that I've created and passing in the splits. Splits contains all the splitted document, the PDFs, and also and it stores the vectorized format into this directory. And so now once we've created this, you should see in your site for uh, inside the folder that contains the vector database. It should be created now in your folder file explorer folder structure. Okay, and then so once you've done that, so in order to you see this the cell number 9, it's for once you have already um, finished creating the vector database and you log off, how do you retrieve it again? You just need to pass in where the directory lies, and then the embedding function, and then the embedding you need to send in like what is the specification for the embeddings, and then it retrieves or sets it retrieves your vector DB from your storage. Okay, so that's how you should be retrieving your vector database. We'll keep it commented because we don't need it now. But if you've already trained this database and then you need to access the database in the future, you can just start from this step. So now, chatting with open. Okay, I see a question there. So embeddings are like word vectors, but for full sentences, phrases, paragraphs. No, they are for the tokens. They're not for full sentences. If not for full sentences or phrase or paragraphs. Okay. So now chatting with OpenAI. So now we get into the more interesting part where we will be starting to chat with the data. what So what we are doing here is we instantiate and say that okay, we are using GPT 3.5 turbo model to interact with the LLM, and I set the temperature as 0. So this is our this is our LLM's specification. Okay, and then we set a memory to to store all the information that the that we are interacting with already with the LLM. So that's how we've done it, setting chat history as memory key and say like return messages true. So therefore it'll it'll return the messages that you have previously talked through with your LLM. Is there any questions so far? I hope everybody is following. So now that we have created this LLM, we have instantiated LLM, we have instantiated the memory retention policy, and we have our we will be designing our retriever. So here what we've done, and so vector DB, as you see here in LangChain, why is it so easy to use? It's because um, it's why is it so easy is because it gives, so it doesn't you don't have to really encode all your similarity strategies. What you can do is you can just set vector DB as retriever, and what the vector DB acts, it's got these underlying modules which does your similarity search for you, and by default it does a similar your basic similarity search. You can use some advanced similarity searches as well, which you can set as search type there, um, right? And then you can give that strategy, but that's all you need to know. That's all you need to do in order to retrieve the context from the vector database. Okay, and that's your retriever. And then you get the conversational retrieval chain, which allows you to interact with the vector database in in vector database while you're conversing. Okay, so you're sending, so this is your LLM specification that you're saying that, okay, I'll be using GPT 3.5, and then you'll be using retriever, this retriever setting, which is your default retriever, and this is your memory setting. So it's going to return the messages that you've been talking, conversing with it, and we run it. And okay, and so once we've done that, it takes some time to build it, and then that's all you need to do. That's your that you've instantiated your conversational retrieval chain. That's where you start asking your questions about the document. Okay, so I'm just gonna run all the cells above. And you should be able to ask questions about your document now. And you notice how it can also detect your um, spelling mistakes as well. Okay, for Chroma DB, I think you will also need to have a Microsoft's Visual C++ tools, build tools. If you've got any problem in downloading that, let me know. Okay. And while you're installing, if you could also do pip install Streamlit, that would help you to run the run the other Python files that I have in there. Okay. All right. So what's the structure here? So initially we saw there's the output for the basic prompting is different. The output for this conversational retrieval chain is different. We've got this question, you have this chat history. So since you returned true for memory, it returns back your chat history there. You can see what you had asked, what was the response, and all of this is fed back again to retain in context. Okay. And so says this is the answer there. What is this document about? This document is about a course offered by Trinity College Dublin in the Faculty of Arts, blah blah. So then you can ask what are the career opportunities. It basically refers back to the PDFs, gets the relevant information, and answers your question. Mm. Says graduates of this course have a range of career opportunities, and that's how. And then there are in high demand, blah blah blah. Tells you what other opportunities you have in the industry and also in the research field, blah blah blah. And then you can continue on this conversation further. Okay. And this is basically the backbone. This is basically the backbone of how your you know how this is basically the backbone of how your chatbot interacts. All you do with Streamlit is you give it an interface. This is your backend. This is your job done. You can definitely try looking at yeah. So it's the backbone of your chatbot, and you've got this you plug it into your Streamlit code after that, and refer it back and forth once you've trained your vector database, and that code lies in the .py files in the talk resources. So let me start sharing. So you can see this. So these .py files, I've got this create.py. This is here I've basically organized the entire code into a command, so I can access this from command line with passing the argument for setting up this chunk size, chunk overlap, and the embedding chunk size if it's required. You can also extend this into choosing ability to choose the kind of model that you want for your embeddings, and also for setting like what is your which directory, what's the path that you want to use, what are the document paths as well, all those things. All I've done here is I put that into a proper dot file dot py script that allows you to train your vector database separately. In the config.py, this is where I've set up all the models, the embedding model that I've used, GPT model that I've used, the directories where I have the data, which key I have with OpenAI key, all those things here. You can definitely take them as inputs, but I've set them up here in the configuration file. I've already looked up create.py, and I have llm.py here as well. So this is where I set up once again the LLM, the embeddings, the vector DB, fetching from my configuration, the path, the OpenAI keys, the kind of model that I've used, and and also I've set up the vector DB with the default search strategy, and then with the conversational retriever chain, so that we sew this as a as a conversation chain, and then we've got this. We've added memory as well to this, and then this is where this is the function that is being called from Streamlit interface every time you enter a prompt. If there's a prompt in it, it hits here and sends the question along with the context, and then it gets a response. So that's the response that is being accessed from the Streamlit front end. The Streamlit front end is also a very small bit of code. That's the web app.py. So it's a very clean code where it says like if there's no message, if there is nothing in the messages, that means that's just the start of the chat, and says, okay, the starting message is howdy. And then over there, um if it finds messages, then it starts appending to it. If there's a prompt in there, then it writes the prompt, shows the prompt up in there after you press enter, and then it basically sends the prompt back into the previous function that I showed in the previous class. And from there it gets the response, and once it gets this response, it again shows it in the front end chat here. Okay. So that's how it works. And this is how you can interact with it. I hope it works. Okay, so it missed some of the context in there. So these are things that sometimes happens. And this is very practical, because it's already missed some context in here, while I while I created this. Now that sometimes what happens is the keywords don't match. So where does the webapp.py run? You have to so let me stop sharing and share my screen again. Um, so I have used PyCharm to so I use it from can you see my screen? So I just go from command line, and in your Python environment, I go Streamlit run uh, webapp.py. If you've Python set up from your command line, you can literally go like you can type this in your command line. Python minus m streamlit run web app. If you cannot access your Python environment from your command line, you can go Python minus m streamlit run web app.py. That's how you have to run it. You have to install Streamlit before that. So this what happens. It runs out of the context window because the context is so large, and sometimes so because even with temperature set to 0, it does. So this response has changed 3 or 4 times now. You have to and what you can do is you can enhance your search retrieval strategies into some other. So I think MM could work very well for this. And then once you've set the context, then you can ask. So and so on and so forth. But like I say, so the limitations here, as you've seen already, if your context window is too large, in that case it'll lose the context because it doesn't know what it and what this will refer to, right? So that's something to take away from here from this talk. And sometimes, so from practical presentations, what I've seen is that sometimes you have to be very accurate on what exactly keywords that you're asking about to the chatbot. So it is intelligent, but it's not like absolutely human intelligent. So when you for example, I'll give you very one of the basic examples that I've seen is childcare benefits, maternity benefits. um, you have to be very specific. It doesn't give you the entire result from there. You have to be very specific about the word that has been written in the document so that it retrieves exact information. It gets confused sometimes about very similar confused between synonyms, and it can also miss the complete context if you give a synonym some time, because it just doesn't know that it's supposed to refer to something that's represented in another word. So you have to be very careful when you deal with this. It all depends on how you have designed it to respond to your prompts, because there are other ways of implementing these. You can use prompt template with context as well to retain your memory as well, the different other strategies to use to improve this. um but yeah, and we can go back to our presentation for the last bit unless there are any questions. Let me just go and check. Have you been able to run web app.py? Mm. Mm. You have to give it some time, I think. Mm. I don't know why you're using org. Uh, mm. Are you using your is this your personal one, or because I haven't seen org in mine. I think it comes when you set up an organization. I have my personal API key, which starts with something like SK or something. But anyway, I think we can take this offline. Says limit 3, use 3, requested 1. I'm not very updated with the with how they have restricted the usages now at this point of time, because I haven't been using my personal key for some time. I used it today, so it works fine, but I'm using a paid plan, which works fine. The cost is not too high, because I was learning. I was like, okay, I can invest that kind a little bit. It's not it doesn't go beyond like I think $5. It doesn't go beyond that at all. Only when I'm testing heavily, only then it goes like that high. Okay, so I will go into the last bit today. The advantages and the disadvantages to summarize. The to access the vast information for context and knowledge, LLMs are fantastic because you are basically utilizing the whole pool of information that is available on the internet, and it can generate coherent and human-like responses as opposed to rule-based engines that would from where you have to only select like a few options, and then if you have anything else to ask, it probably wouldn't be able to answer any questions. But with the LLMs and the current state of the art models, you can build a more more friendly and welcoming and more accurate environment for your customers to interact with in on their chatbots. It can also offer creativity like generating stories and open-ended question answering, any kind of template generation like we've already seen before. And then the most important part here is performance and speed, especially for OpenAI. The performance and speed accuracy has been really massive. Speed is it does the job in a few seconds, whereas I've tested with llama before. It takes a bit of a time to generate responses. The performance is not at par with OpenAI as far as I have seen. So but then in general with OpenAI, and it's been used for lot many purposes. um they for the performance and speed has been phenomenal for basic use cases. And then for in terms of the disadvantages, yes, hallucinations is something that we all need to be careful about from OpenAI. You know it's very risky in the industry to produce hallucinations and present it to the users, because that can cost you a lot. It relies on pre-existing data and could therefore have outdated information, right? And we've already seen that. And then biased or inaccurate data as well in terms of the disadvantages. Although I had personally, tried checking uh, biasness in the model where, I asked for like, can you tell me five or six leaders in AI domain, or leaders in the world, like uh, political leaders as well, astronauts. And what it very well does is it lists a good mix of gender um, when it presents the names. But that also shows that they have invested good bit of time in removing biasness. Like I said, that it's really really not very, we cannot we it's too huge data to pick out every single biasness, every single problematic harmful content, you know unsafe content from the database. So therefore LLMs are prone to having these biased or inaccurate information that you're not supposed to show, which does not follow proper protocols, or hate content, hate speech, all those kind of things. And then resource intensive fine tuning. So when if you want to fine tune is not the best to use in terms of using LLMs. Few shot learning works the best. That's what have been established so far. Few shot learning with some examples and giving clear instructions gets everything done. So fine tuning, it would only be necessary for very specific use cases that cannot be handled using few shot prompting, few shot learning. Um, or in that case zero shot learning, because you see things like sentiment analysis or sentiment classification is now just like zero shot learning. You don't even have to give examples. You have to give examples only when you need it in a certain format. So if I just say, can you give me the sentiment um, for a particular sentence, it'll tell you uh, this sentiment is negative. Okay, it could say negative, it could also say zero, it could also say -1, but you need to set a standard and say, hey, if it's negative, give me zero. If it's positive, give me one. Or or if it is negative, give me n. If it's positive, give me p. You have to in that case you have to give examples and set the context and tell the LLM to give you the response in that particular format. And that's very important. So that's the disadvantage of the LLMs. But all in all, we have a future that we cannot deny that LLMs and OpenAI, not just OpenAI, these HuggingFace and Llama, Bard, they're all going into the future. I think 2024 is even more exciting to see where we go, where we land up with this highly efficient language models that has the ability to now think and answer like humans. Where do we go next from here? It's an interesting conversation for next year. I have also added some references that I used to create the slides and also the notebooks for today. There are some of the great one of my favorite ones for LangChain to learn LangChain, I think, is this one, the third one. And I've been using that, and also the LangChain docs. The LangChain, the documentation is really good. So if you want to explore more or learn more about about LangChain, what are the other strategies that you can use, because this is just a sneak peek of like you doing it at a very high level. What other things you could do? It's you feel free to explore that. What we've just done is we've actually used RAG, strategy retrieval augmented generation, where we've searched and given the retrieval strategy and the retrieval context along with our prompt. So we've actually done RAG strategy just right now. And so if you want to read a little bit more on that, that's there from IBM's research. Yep. And yeah, that's it. Hope you've learned something from this, and let me know if you have more questions.